If you clicked in this video, you probably want to give your circuit a better look and try to design your first PCB. I'll guide you through the whole process and show how to give your circuit a clean and professional look. If you like those kind of videos, make sure to subscribe. Let's get started. So after you come up with an idea to implement, the first step to take could be writing a sort of diagram block on paper to better visualize our concept. Although I must admit, really often I will go directly into step 2, which is breadboarding. We take our breadboard and we put our circuit all together. And remember, the whole point of breadboarding is basically make sure everything works as expected. You don't want to spend hours designing your PCB to just throw it away because it doesn't work. Although failing is a really good way to learn. So here we build our circuit, program our microcontroller, check for voltages and currents, we visualize the waveforms and make sure everything works fine. After that, we want to draw our schematic, and to do this we have to use an EDA software. The one that I use is KiCad. It's totally free and comes with all you need to make your beautiful PCBs. So we download KiCad and then we create a new project. Okay, the first component that I need is the LMV358. So we press 8 and we search for it. And pay attention, this is not your standard LM358, which is not rail to rail. Anyway, this is the symbol, and down here we have all the various footprints. Make sure you choose the correct one, otherwise you won't be able to solder your component. Okay, now we can rearrange our components, and to add the wire we simply press W on the leads of our symbols. The next component that I need to add is a capacitor, an electrolytic one. So again we press A, and to search capacitor you only need to type in the letter C. I'll go for a polarized one. We place it and we wire it to our operational amplifier. Then I need a resistor, and to search for it we only have to type in the letter R. And we place it before the capacitor to make our RC filter. We can also modify the value of our capacitor by double clicking on the text here. And the same goes for our resistor. To access the properties of your component, you can simply click on it and press E. Here we can, for example, change the footprint, and as always make sure to choose the correct one. You can find the footprints and dimensions in your component's datasheet. Or you can go the old way and use a caliper. Now another thing you want to do is to add the ground symbol in your schematic. To do this, simply press P, and that stands for power presumably, and just search for GND. Again, by pressing P you can also add your VDD symbol. Now another interesting feature are the global labels that are useful when you want to connect two components that are far apart in the schematic without using long wires. You simply give a name to your label, you then choose input or output, and you can connect it to your component. Okay, I completed the schematic. I've added the input and output connectors, and also an LED to know if there is power or not. And we want also to check for errors. We click here on the DRC, we run the DRC, and as you can see we have no errors, so our schematic is fine. Okay, now to access the PCB editor we simply click on this icon here, and boom, we are in. The first thing you want to do is import your footprints, so we click here on the top. If you see no error, then it's all good. You have all your footprints and they're all good. Now we can start rearranging our components. There is sometimes a trade-off between a good looking PCB and an easy to route PCB. Although if it is this simple, there is really not much to worry about. If you want to access the properties of a footprint, you have to click on it and press E. Here we can, for example, change the position, or we can also modify the footprint itself. Okay, now if the layout looks good to you, we can finally proceed and route our PCB. But we have to make sure we choose the correct size for our traces. If your trace is too big, you risk to waste some space, whereas if it is too small, you have more resistance, that means more voltage drop, and maybe your trace cannot even handle the current you need. So basically, the higher the current, the wider the trace. Anyway, I'll go with 50 mils and route all my traces except for the ground ones that need a special treatment, because it's often common practice to use a full ground plane for our ground connections. Although if your PCB is this simple, you can also go with standard traces. Now that we completed all the routings, we can move to the Silkscreen layer. We can generate some text, for example, by clicking on the T down here. We can write, for example, G and D. That will be our label for our ground pin, and we can place it here. We can do the same for the other pins, and if we want to give more importance to one pin, we can always make it bold. To do this, we simply access the properties of our text and click on the bold icon. Another interesting feature could be using the knockout, which basically it's the negative of the text, so the silkscreen now becomes the contour of your text, which is often used in labels and aesthetic stuff. Of course, in the silkscreen layer you can also add all sorts of shapes. I've also added my own logo. I made a video on how to add the pictures or logo in your silkscreen layer, so make sure to check that video if you are interested. Let's move on to the next topic, which is edge cuts. After you completed the silkscreen layer, we can move to the edge cuts layer, which is down here, and we can draw a shape, and this shape will be the contour at the limit of our board. Sometimes you want rounded angles, and to do this you click on the shape, right click, and then we can use this tool here, fillet lines. We click OK, and you have here this round shape all around your corners. Okay, I've also added the 4 and 2 mounting holes for my board, and if you press Alt 3, we can access the 3D editor. One last thing you want to do before completing your board is checking for errors, as we did with our schematic. So we run the DRC, and as you can see here I have 4 warnings, but these are not important, so we can proceed. Normally what we will do now is basically generating the Gerbil files for our PCB, but I have a better option, that is using the PCBWay KiCad plugin. To install it, we have to go to the home page of our project, click on the plugin and content manager, and then the fabrication plugins. You can see there is right here. We click on install, and we then click on apply pending changes. After the installation has finished, you can go back to the project and click on the PCBWay icon at the top here. And the plugin will redirect you to the PCBWay site with your project already loaded into the site. So here we can change the number of PCBs that we want. We can go really up to 1,000 and more. We can also modify the substrate material. And normally you wouldn't touch this, but sometimes you need to handle higher temperatures, so you need to change your substrate material. You can also change the PCB thickness. The standard one is 1.6 millimeters, and you can go higher or lower. And pay attention, this is not the actual height of your copper, it's not the thickness of your copper, it's just the thickness of your PCB. Then we have minimum track and spacing, so if you use really thin traces or your traces are really close to each other, you have to modify this number here. And of course the same goes for your PCB holes. Then we have the color of our solder mask, which is actually the color of our PCB. And by the way, PCBWay has also a limited offer for purple PCBs up to the 31st of October. And then we have surface finish of our PCB, which is basically the layer that prevents oxidation of our pads. Then we have the copper thickness, which is actually the thickness of your copper layer. Normally you wouldn't touch this, except in case you want to handle a really high current. After that, you can choose your favorite shipping method, and then you're ready to go. But PCBWay offers also 3D printing and CNC machining with really lots of material you can choose. So make sure to check PCBWay.com using the link in the description. There we go, guys. We have the PCBWay package here. I have my PCBs. Look at this. These are not the one that I showed to you. Look at this. These are super cool. Actually, the one that I showed in the video are those one. Look at this. Super cool, super fancy, and now we're gonna solder them. The first part that I'm going to solder is the operational amplifier, because it's the only SMD part. SMD components are basically solderable only on one side. This one has a big package for the SMD word, and their pins are quite separated from each other. So it's fairly easy to solder it even with a standard soldering iron. After that, we insert our through-hole components and then we solder them. After soldering, we have to remove those leads here, and to remove them we can either use a cutter like this one, or we can use a nail clipper like this one. And there we go, we did it. As you can see now, the board is without long leads. If you don't want to go through the hassle of soldering your components, or you have bad joints like mine, you can always use the PCBWay assembly service. You just have to compile the bill of material, you have to insert all the components you want to be soldered, and the PCBWay team will solder them for you. Anyway, it's now time to finally test the board. Okay, I have my board here. I've already powered it on, and I have an encoder. That basically will ask the MCU to increase the duty cycle the more and more I turn the encoder. And so with an increasing duty cycle, I have an increasing analog voltage. So we effectively turned our PWM signal into an analog signal. I've also made a breadboard compatible PCB that works as the same. We basically have the encoder that asks the Arduino Nano to increase the duty cycle of our PWM signal, and then the PCB converts it in analog voltage. Okay guys, tell me what you think, subscribe, and see you next time. Bye.